is Algebra 2. We're doing lesson number 69. And we're going to talk about more gas law problems. We're starting on page 291. We already know that the gas law for a fixed amount of ideal gas can be written as the initial pressure times the initial volume over the initial temperature, which equals the final pressure times the final volume over the final temperature. Instead of just substituting values into the equations this time, we're going to start by solving for one of the variables. And they're throwing in lots of scientific notation just for fun. So here's our first example. A quantity of ideal gas had an internal pressure, volume, and temperature values of 40 times 10 to the 4th atmospheres, 0.0003 times 10 to the negative 6 centimeters cubed, and 700 times 10 to the 4th kelvins. Find the final temperature if the final pressure was 0.0004 times 10 to the 15th atmospheres, and the final volume was 0.015 times 10 to the negative 14th centimeters cubed. Begin by solving the equation for the final temperature. Okay, so if we're solving the equation for the final temperature, the first thing we're going to do is eliminate these denominators by multiplying both sides times T1 and T2. So we have P1V1 T1 equals P2V2 T2. We're going to multiply this time 1 times T1 T2. And we're going to multiply this side by T1 T2. So on this side the T2s are going to cancel. On this side the T1s are going to cancel. And you're going to end up with T2 P1 V1 equals P2 V2 T1. I highly recommend you memorize this form of the equation, because for a lot of these problems they're going to have you start by solving the equation for, and if you start here you don't have to do all this again. Okay? T2 times P1 times V1 equals P2 times V2 times T1. Just flip the 2's and multiply. Flip the T's and multiply. Okay, now we can solve for T2. So T2 equals, we're just going to divide both sides by this. So it's going to be P2 V2 T1 over P1 V1. Right? And now we can plug the numbers in. So T2 equals, P2 was 0.0004 times 10 to the 15th atmospheres times V2, which was 0.015 times 10 to the negative 14th centimeters cubed, times T1, which was 700 times 10 to the 4th Kelvin. I keep saying Kelvin. Kelvin. Over P1 was 40 times 10 to the 4th atmospheres times V1, which is 0.0003 times 10 to the negative 6 cubic centimeters. And then you punch all that into your calculator and you get 3.5 times 10 to the 5th kelvins. Make sure you have kelvins. We're ending up with temperature. You need to end up in kelvins. So 3.5 times 10 to the 5th kelvins. That's really hot. Okay? Remember this. We're going to be using that again. Here's another example. A quantity of ideal gas had initial values of 0.003 times 10 to the 14th pounds per square inch, that's the pressure. 0.0007 cubic centimeters, that's the volume. And 7,000 Kelvin, that's the temperature. Find the final pressure if the final volume was 3 times 10 to the 2 centimeters cubed, and the final temp was 0.003 times 10 to the 7th Kelvin. Solve for P2 is the first step. Okay, we're going to start with this form of the equation. So t squared P1 V1, not t squared, T2 equals P2 V2 T1. We're going to solve for P2, so we're going to get rid of the V2 and the T1 and put them over here. Okay, so P2 equals T2 P1 V1 over V2 T1. Okay, so T2 was 0.003 times 10 to the 7th Kelvin. P1 was 0.003 times 10 to the 14th pounds per square inch. We don't need that in there right now. V1 was 0.0007 cubic centimeters over volume 2 was 3 times 10 to the 2 cubic centimeters, and T1 was 7,000 Kelvin. Okay, you punch this into your calculator and you get 3 times 10 to the 7th, and we're talking about pressure. In this case, our pressures were in pounds per square inch, so pounds per square inch. Okay? And that would be your final answer. That's it for those. Try your practice problems. Let me know if you have any questions. Thanks!